Hey guys, today I'm solving Leetcode problem 704, binary search.
So given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with big O log n runtime complexity.
To start, I'm going to explain what the binary search algorithm is. So here I just have an array of elements. The normal way of searching through an array like this would just be to visit every node. So let's say our target is 5. So here's 5. We're gonna first visit the first node, right? Not in here. The second node, and we're gonna do this all the way until we get to 5, right? And this is how it normally is. This time complexity is linear, right? So at the worst case, 5 may be all the way at the end of the list, and this is pretty inefficient. Think about this at a larger scale. So say like here we only have like 6 values. Let's say we have 1,000,000, right? If 5 is all the way at the end of this list, it's gonna take 1,000,000 iterations to reach this. So there is a better way we can do this with a binary search algorithm. So let me show you what that is right now. So for starters, we're gonna have 2 pointers. One's gonna be pointing at the front of the list, and the other one's gonna be at the back. And we're gonna have a midpoint, which can be either 3 or 5 if our list is even. Now what's gonna happen is we're gonna compare our target to the midpoint, right? We have 3 and we have 5. We obviously know this is less than 5. Now we're gonna shift this left pointer towards mid, and what this is gonna do is it's gonna knock out basically half of this array. Now we don't even have to look at this, right? Now we're gonna recalculate mid, right? So now instead of mid being on 3, now it's gonna be on 9, and then we're gonna run this all over again. So this time, now we're gonna shift this right pointer to mid, but not exactly mid. We're gonna shift it to 5, and I'll explain this. I'll explain these little details in a second, but we can see that on each iteration, instead of just going through one element, we're instead splitting the list in half each time, and that's much more efficient than going through each element with that being linear time complexity when this is big O of log n. And this example is for when there is a value, when target is in the array. But let me show you an example where there isn't. Let's say our target is 2, and we're gonna do the same setup as before, right? We're gonna have 1 pointer at the front, 1 pointer at the back, and we're gonna have a midpoint. So by the end, we're gonna be right here, right? But we're already done here, right? These pointers can't move anymore, so we're just gonna return false, right? Because it's not in here. And we're gonna have a check to make sure these two pointers never cross each other. For the binary search algorithm to work, the list needs to be sorted. When we compare down here, this is assuming that everything after 3 is greater than, and everything less than 3 is less than. Like I said before, we're just gonna set 2 pointers, right, left and right. And we're gonna start one at 0 and the other one, because this array is 0 indexed, or by default 0 indexed, that the last element is on is offset by 1. So we're just offsetting it. We're gonna do while L is less than or equal to R. That's gonna make sure that the 2 pointers never cross each other. So now we have our left and the right pointers. Now we need to set our mid pointer, and this is going to divide this by 2, but not give us a remainder. Next, we're gonna start with our conditionals. So when target is less than our number at mid, we were gonna update our right pointer, right? That's what we did in our example. So right is now gonna be equal to mid, and remember we need to offset this by 1. Next, we're gonna check the opposite of this. So, and just like before, this time we're gonna be updating the left pointer, and instead of subtracting 1, we're gonna add 1 because we're going in the opposite direction. In our last case, so we checked if it's greater than or less than. Now if it's equal to, and we don't have to write this out, we can just do else. This else is basically we found our number, right? Here we're not gonna return the number, right? We're not gonna return the number, we're gonna return the index. Conveniently, our index is going to be on mid, right? So all we're just going to do is return mid. So now we have this algorithm, but what if on the base case that our target isn't in num? This isn't going to account for it. When this while loop ends, it gets through this while loop, it doesn't find our target number, we're just going to return -1 like it said. And this is all the code, pretty straightforward, and we can see this is pretty efficient. This is only one way to write the binary search algorithm. This is definitely the most straightforward version, but there are definitely other ways you can write this, and I might cover the other ways in another video. But I hope this was helpful, and thank you for watching.